Now we'll solve a little bit tricky problem, a little complicated problem. So here we'll try to prove that square of any positive integer is of the form 4q plus 1. Okay, you take any positive odd integer and you square it, it will be in the form 4q plus 1. Alright, so that's what we'll do. So what we want, let a be any positive integer. Alright, let a be any positive odd integer. Okay, so when I square this one, the resultant will always be in the form 4q plus 1, where q is an integer. Alright, okay, so that's what we'll do. Since a is any odd integer, what we'll do, we will assume a to be in the form 2m plus 1, which we have already proved. That any positive odd integer, when you divide by 2, then the quotient will, in this case I am taking quotient as m because q is already there in the quotient. So we'll take it as m, and the resultant and the remainder will be 1. So a is now written as 2m plus 1. Alright, so you could have taken it as 4m in the form of 4m, either it will be 4m plus 1 or 4m plus 3, and you can square it and check, but that will lead to a lot of complications. We'll take simplest one, 2m plus 1. Another reason to take 2m plus 1 is that when you square this one, so 2m whole square now becomes 4m square. So 4 is already there. So we don't have to take next one, 4m plus 0 or 4m plus 1. Alright, this is how you realize whether to take 2m plus 1 or 4m plus 1. This is what you have to realize. Alright. Okay, so now let's take a is in the form 2m plus 1. So what are we trying to prove is that when I square a, the resultant is of the form 4q plus 1. Is it correct? So what we'll do, we'll square this one. So squaring on both the sides. Squaring on both the sides. So what do we get? So a square now is written as 2m plus 1 whole square. So 2m plus 1 whole square, please don't write it as 4m square plus 1, that will be wrong. This is of the form a plus b whole square. So a plus b whole square is a square plus 2ab plus b square. So let's write that one. So a square is 2m whole square plus 2ab. So 2 into 2m into 1. A is 2m and b is 1, correct? Plus b square, which is 1 square. Now you see this one. So what is this? 2m whole square is 4m square. Applying laws of exponents, you can take 2 separately to 2 and m, so it will become 4m square plus 2 into 2m is 4m plus 1. Now interestingly, between these two, what can I take outside? Don't take 4m outside, we'll just take 4 outside because we want in the form 4q plus 1, where q is an integer. Alright, so let's see this one. If I take 4 outside, remains m square plus m plus 1. Now we will apply the integer properties. We know m is an integer. Alright, let me write it. Where m is an integer. Correct. So obviously quotient will always be an integer. Correct. So we already know that m is an integer. So m square of an integer. So when you multiply m by m, the resultant is again an integer. M is again an integer. So this is integer. I am adding integer plus integer. So when I add integer plus integer, this resultant is again another integer. So this another integer, I will write it as q, some integer q. So this can now be written as q plus 1, where q is another integer. So essentially a square is now written in the form 4q plus 1. I hope you understood this one. So what was the argument here? Argument here is that since I want any odd positive integer, we will assume that it is of the form 2m plus 1. So when I square it, so I get this one. So when you take 4 outside, m square plus m is again an integer, which I will write it as some integer q. So this is now written as 4 into q plus 1. I hope you understood this one. Alright, we will solve few more complicated problems similar to this one.